Hi, salam alaikum. Greetings to you from wherever you are watching this video. So today we are going to look at polar form of complex numbers. So we say a polar form of a complex number involves the basics. So you have to understand the basic form of complex numbers, where we say a complex number is represented by a plus bi, where a is the real number and b is the imaginary number. So in this form of complex numbers, we call it Cartesian form or rectangular form of complex numbers. But for a polar form of a complex numbers, so we don't write complex numbers in this way. So they are written in this way. Yeah, z is equal to r theta. So there is a new idea you have to learn from polar form of a complex numbers. So you have to know how to get the modulus of a complex number. So what is meant by the modulus of a complex number? A modulus of a complex number is the length of a complex number from the origin. It is the length of a complex number from the origin. So from a point where it is located on Aragon diagram. So while the argument is the angle that is sustained by the complex number. So in polar form of complex numbers, you have to know about these two: how to get the modulus and how to get the argument of a complex numbers. And then you write in this form: z is equal to r theta. R represents the modulus and theta represents the argument. R represents the modulus and theta represents the argument. So let us learn here how to get the modulus of the complex number. So assuming we have a complex number which is located here, complex number z is equal to a plus b I. So with this complex number, a is the real number and b here is the imaginary number. So the length of the complex number is along this line from the origin to this point. So this line is what we call the length of the modulus or the modulus of complex number. So it is represented by letter R. So the angle is here. The angle sustained by this complex number from the real axis, So this is represented by theta. So to write this complex number in polar form, we say that z is equal to r then comma theta. So this is a way of representing a complex number in polar form. So the other way of representing complex numbers in polar form, we say z is equal to r outside bracket cos of theta plus I sine theta close bracket. So this is another way of expressing complex numbers in polar form. Z is equal to r outside bracket cos theta plus I sine theta. For this one here, r represents the modulus. If you know how to get r, then you will substitute it here. You see, while theta here represents the argument of a complex number. Theta represents the argument or the angle of complex number. If you know how to get the angle there, it is going to be fine to solve these complex numbers. So now, assuming you have a complex number, z is equal to 4, then 30 degrees. So what does this one mean? It means that 4 here is the modulus of the complex number, while 30 degrees here is the argument of complex numbers. So this can be plotted on Aragon diagram in this way. This one is the real axis and this one is imaginary axis. Okay, to write this one or to plot this one here on Arrogant diagram. So what you have to know is that 4 represents the modulus, that is the length of the complex number, while 30 degrees represent the argument, that is the angle. So the angle subtained here is 30 degrees. So while the length of the complex number is 4, this one is 4 units. So this is how you can plot a complex number z is equal to 4 then 30 degrees. So to write it in other form of a complex number, where we say z is equal to r cos theta plus I sin theta. So in this form of a complex number, in this form of a polar form, so we can express that one as z is equal to r which is 4 here, the modulus is 4. So we can say z is equal to 4 outside bracket cos of 30 degrees, angle that is 30 degrees, then plus I sin theta which is 30 degrees. So this is how you can write it in polar form. If you are given the r which is the modulus and the argument which is the theta, you have to remove this thing, then you substitute with their values. Okay, that is the polar form of a complex number. So if you are given you get r of a complex number, r to be 2 and theta to get it as what, as 60 degrees. So what can you do here? To write it in polar form, z is going to be equal to r which is 2. You say 2 outside bracket cos of theta, and theta here is equal to 60 degrees. 60 degrees plus I sin 60 degrees. So this is the polar form of a complex number. Okay, let's have another one where we have r is equal to root of 2, assuming the modulus is equal to root of 2 units. So an angle is equal to 90 degrees. So how can you write this one in polar form? You will say z is equal to r which is root of 2 outside bracket cos of angle 90 degrees plus I sin of 90 degrees. So this is the polar form of a complex number where you have r is equal to root of 2 units and theta is equal to 90 degrees. So now what we have to learn after getting those concepts, learn how to get the modulus. How do we get the modulus? So now we can have our complex number a b, that is a plus b. So where this length here is a and this one here is b, the imaginary part is b. So this one is the r. This is the modulus of the complex number. So and this one becomes the angle theta. So how do we get the modulus of a complex number, this length? How do we get that length? That length is what we call the modulus. So we use the formula of Pythagorean theorem, where we have a square plus b square is equal to c square. If we use this formula here, we will get r, which is the modulus of a complex number here. Real number is square, a square plus b square is equal to hypotenuse, which is equal to c here. So r square. So now if you need to make r the subject of the formula here, you have to put both sides under root, the right hand side and the left hand side under the square root. So for this one here is square root, will cancel with the square, then you remain with r. So modulus, which is r, is equal to root of a square plus b square. So this is the formula for getting the modulus of a complex number. So if you are given any complex number and you are told to find the modulus of a complex number, you will say that modulus, which is represented by r, is equal to square root of a square plus b square, where a represents the real number. A represents the real number, while b represents imaginary number. You see? So that is the formula for modulus. Assuming you have a complex number, z is equal to 4 plus 3i. So how do you get the modulus of this complex number? So what you have to do is say that solution. Then you say here that the modulus of complex number is equal to square root of a square plus b square, where a represents the real number. So our real number here is 4, that is a, and imaginary number here is 3. Just take only 3, the coefficient of I. Don't say 3i square. So just take the coefficient, which is 3. So here you will have the modulus is equal to 4 square plus 3 square. So 4 square is 16 plus 9, which is 25. So it is going to be square root of 25, which is equal to 5. So the modulus of this complex number is going to be 5. It's going to be 5. So that is how you get the modulus of a complex number. That is how you get the modulus of the complex number. This is 5 units. Okay, now since you have learned how to get the modulus of a complex number, so you also need to know how to get the angle of a complex number, the angle here, this one here. So how do you get the angle? Theta. So if you use the knowledge of trigonometry here, you know that this one is opposite, you see, and this one is adjacent, and this one is hypotenuse. So what trigonometry function relate the two, the opposite and adjacent? It is tan, right? So tan theta is equal to opposite out of adjacent. So since tan theta is so, you will say tan theta here, tan of theta is equal to opposite, which is b, is equal to opposite, which is b, out of what? Out of a, which is the adjacent here, out of a. So therefore, to get theta is equal to tan inverse of what? Tan inverse of b out of a, tan inverse of b out of a. So this is how we get theta. Theta is the same as what? Is equal to tan inverse of b out of a. So it means that you divide b by a, which is imaginary number, divided by real number. Okay, for this complex number where you got it modulus before, you get the angle of this one here by using that formula. So to get the angle of this complex number, you can easily say here theta is equal to tan inverse of b out of a, where b represents the imaginary number, which is 3. So this is going to be tan inverse. Theta is going to be equal to tan inverse of what? Of 3 out of 4. So because 4 here is the real number, So now you press your calculator press shift. If you have call it there, shift. Okay, so you press shift, then press tan. Now you'll have tan inverse. Then write 3 divided by 4. So tan inverse of 3 divided by 4 is equal to 36.9. So your theta here is equal to 36.9 degrees. So this is going to be the angle between the real axis and the complex number z. So this is how you can get the modulus and the argument of a complex number. So use these two formulas. Theta is equal to tan inverse of b out of a. So in a place where you are using x and y, so a represent x value and b can also represent y. So in other way, you can say modulus, which is r, is equal to square root of x squared plus y squared. So you can say modulus r is equal to square root of x squared plus y squared. And if you are getting the angle, so you can also say theta is equal to tan inverse of y. You can replace b with y divided by what? X. So y represents the imaginary number while x represents the real number. So you cannot be confused, because in some books you will have x and y. So if you know how to get theta and you also know how to get the r, the modulus of a complex number, it is easy to write a complex number in polar form. So like for this one here, we got r before as 5 and we got theta as 36.9. Can we write it in polar form? Z is equal to 4 plus 3i. So the r we got before is 5 units. And theta was 36.9 degrees. So this was the value of theta. How do we write this one in polar form? The polar form of complex number is z is equal to r outside bracket cos of theta plus I sine theta. Then this is the polar form of a complex number, or z is equal to r comma theta. So can we write it in this form, this complex number in this form? Okay, so let us do it. So here we will have z is equal to r. The value of r here is what? Is 5. You replace r here with a 5. Z is equal to 5 outside bracket cos of what? Cos of theta. What is our theta here? Theta is 36.9 degrees. So cos of 36.9 degrees plus I sine of what? Sine of 36.9 degree. So this is the polar form of this complex number. So if you have a number in rectangular form, you can easily solve it by getting the r and the theta of the complex number. Then you just go straight to this point, write the polar form of a complex number, then you substitute the values of r and theta. So I think now it is clear for you to write complex numbers in polar form. So you have an example here which is given to you. You see this complex number z is equal to 4, then the angle given there is 40. So you are being told to write it to draw it on Argand diagram. So, and also you are being also instructed to write it in rectangular form or Cartesian form. So let us see. Okay, to plot it on Argand diagram, you have to know that 4 represents the modulus, which is this one here, the length. This is the length, which is 4. Then 40, this angle is the angle here, angle between the real axis and the complex number here. So this angle is what is being represented by 40 degrees. So you can easily know it in that way. You see, modulus is 4, the argument or the angle is 40, and this is the way you can write it. Okay, now what they are now looking for is again to find the what, to write this complex number in Cartesian form, in this form of z is equal to a plus ib. So you can write it in this way, you know. So let us find it in this form, Okay, let's say this one represent a, that is horizontal axis, and this vertical axis here, the length to the point P, let us represent it with a b, which is our imaginary uh, number. So for us to get a and to get b, let us start with the a. So we need a trigonometry function that have relationship with the what, with the a, and this part which is hypotenuse r, the modulus. Which trigonometry function has the relationship there? We use cos. Cos is set. Cos theta is equal to adjacent. Out of hypotenuse. So this is for cos. So since our adjacent here is a, since adjacent there is a, so we can substitute it here, and hypotenuse here is 4. So we are going to substitute it there. So we can easily get this by saying that we will have cos of what? Cos of theta is equal to adjacent, which is what? A. Adjacent is what? Is A, divided by hypotenuse, which is the modulus. We said before, we usually represent it with R. So here, let's make A as a subject. So to make A as a subject, we have to multiply both sides by R, such that R cancel here, and then you remain with A alone. So A is going to be equal to R cos what? Cos theta. So for you to always find the real part or real number of a complex number, you have to multiply the modulus of a complex number by cos theta. So don't forget of this, because you will not be always driving this thing here. What you have to know is only this part here. A is equal to R cos theta. Okay, now since we have already known the formula here, we need to wrap it away, and then we find what? B. How do we get B, which is this part? Okay, now let us look for another trigonometry, which is the ratio of opposite and hypotenuse. So for that case, we know sine of angle theta is equal to opposite, out of hypotenuse. So for this one, we will have sine theta is equal to opposite, which is b. Opposite, which is b. So it is going to be b divided by modulus, which is always represented by what? By r. So here we have to make r the subject, b the subject. So we multiply both sides by what? By r, so that b remain alone on that side. So r and r cancel. So you will finally have b is equal to r sine theta. So this is the formula for getting the imaginary part of a complex number. So b is always equal to r sine theta. So that is it. Now let's summarize. A, which is the real part of a complex number, is equal to r modulus times cos of angle theta. A, which is the real part of complex number, is always equal to R, which is modulus times cos of the angle theta. While B, which is the imaginary number of a complex number, is always equal to R, which is the modulus times sine of the angle theta. So these are the two formulas for getting A and B when complex numbers are given in that form, in polar form. When complex numbers are given in polar form and you are told to get A and B, so you can use these two formulas. That is when you are always writing. That is when you are writing in Cartesian form or rectangular form. So now, since we have known how to get the formulas of writing number in rectangular form or Cartesian form, so let us solve this number here to get the value of A and B, the real number and the imaginary number of that complex number. So let us start with the real number, which is A. So A is equal to R cos theta. So we will substitute the value of R. The value of R is the modulus, which is there as it is 4. So it is 4 times what? Times cos of the angle. Angle given here is 40 degrees. So what is going to be the value of A? So you have to press your calculator. 4 times cos. Just press cos 40 degrees. So here you will get 3.06, which you can just write as 3. You can write it as 3. A is equal to 3. So let's find the what? B, the imaginary number. Imaginary number B is equal to R sine theta according to the formula before. So therefore B is equal to R, and R here is given as 4. So it is going to be 4 times sine of what? Sine of theta, and theta here is given as 40. Our angle here is 40 degrees. So B is going to be equal to so you have to press your calculator again. 4 times sine of 40 degrees, you will get 2.57. So you can write it as 3. So you round that one to be 3. You round that one off to be 3. Okay, now to write it in Cartesian form, in this form of a complex number, Z is equal to A plus B. So to write it in this form, Z is equal to A plus IB. So you have your A is what is 3 and B is also 3. So now substitute B and A. So you will have Z is equal to 3 plus 3I. So this is the complex number in Cartesian form. This complex number in Cartesian form or rectangular form. So as simple as that. Okay, you can see it here. What we got before, you see, these are the things we got. Here we have to look at this thing. We explained this one earlier about getting R, which is the modulus. How to get the modulus, you can see here, and how to get the theta of the complex numbers. So this is the modulus R, this one is the theta or the argument of a complex number. So we look at that. So just go through this one as a revision. So these are the two formulas for getting both the real number and imaginary number when the complex number is given in polar form. So we have the other form here we talked about earlier. So these are the two ways which represent the complex number in polar form. Okay, example 2 here, we are being told to convert a complex number z is equal to 6, then the angle is 110 to Cartesian form. You see? Okay, for us to convert this number in this form, in Cartesian form, in form of z is equal to a, which is the real part, plus I b, and b is the imaginary number. So to get those two, imaginary number and real number, so we have to say a is equal to r, and r is what? R is the modulus, which is there, 6. So you will say 6 times cos, the formula of before, r cos theta, and theta here is 100 and what? And 10, 110 degrees. Here you will get a is equal to negative 2.05 as the value of a. So now come to value of b. So b is equal to r sine theta. So r here is 6, then write sine theta, and theta is 110 degrees. 110 degrees. Therefore, b is going to be equal to 6 times sine 110. It is going to be 5.6. Now to write it in Cartesian form, which is this form, we are going to have z is equal to a, which is negative 2.05 plus the imaginary number, which is 5.6 I. So this is the rectangular form or Cartesian form of a complex number. Z is equal to 6, then the angle is 110 degrees. So that is it. This is the polar form of that complex number, the polar form. So in the next one here, you will have this one here. You see, z is equal to negative 2.05, which is the real number, 5.64, which is the imaginary part. Okay, now let us come to example 3. So example 3 is saying express 4 plus 3i in polar form. Express this in polar form. So it seems like we did this one so before. Okay, let us start. To write a number in polar form, you have to get the modulus first. Find the modulus first, that is r. You first find value of r. After that, then you need to find the value of theta. So when you are writing in polar form, so to get the value of r, let us start with the r. So we say that r before is equal to the square root of a square plus b square, where a represents the real number, which is 4. So it is going to be the square root of 4 square plus b, which is the imaginary number, which is 3 there. So plus 3 square. So r here is going to be equal to 4 square is 16 and 3 square is 9. When you add it, it's going to be 25. R is equal to the square root of 25, which is 5 units. So R is equal to 5 units. So now you are done with R. You need to come to theta. How do you get theta? So the right formula for getting theta before is theta is equal to tan inverse. Tan inverse of y, or tan inverse of b out of a, or y out of x. So any way you can write. So value of theta is equal to tan inverse of what? Of b, and b is the imaginary number, that is 3 alone. Just take 3, neglect I, so it is going to be tan inverse of 3 out of 4, and 4 represents a. So therefore theta is going to be equal to tan inverse. So to press it in your calculator, so press shift, then press tan, then 3 divided by 4, then you will have here 36.87. So this is what I got. Theta is equal to 36.87. Now since you have the value of r, which is 5, and value of theta, which is 36.87, so you can now write it in polar form. And you say before that polar form is this form: z is equal to r outside bracket cos theta plus I sin theta. So now replace r and replace theta. So therefore we are going to have z is equal to r, which is 5, times cos of theta, which was 36.87 degrees plus I sine of 36.87 degrees. So this is the polar form of a complex number, or z is equal to r, then the angle. R is what is 5, and the angle here is 36.87 degrees. So this is the polar form. That is how you can express a complex number in polar form. So let's see it here. The modulus here is 5, which is this. We already did this. Then the angle theta here is 36.87, which we already got. So this is the polar form of a complex number. This is the polar form of a complex number. So let's come to example 4. Example 4. So example 4 here, we say z is equal to a plus bi is the rectangular form of a complex numbers, or Cartesian form of a complex number. So now you are being asked to write this complex number. Z is equal to 5.831 times cos 59.04 degrees plus I sine 59.04 degrees. So you are expressing this number, which is in polar form, in what? In form of a plus ib. This is what they are telling you to do. So you have to get the value of a and to get the value of b to express it in a rectangular form. You get that? This is where you have to determine the values of a and what and b. Okay, now let's do it here. Let's do it together. So we need to do it together. Okay, look, this one here is the r, which is modulus of a complex number, and this one is the angle, which is theta. You see, this one is theta and this one is the modulus. So how can you get a? In the formula before, to get the a, we have to say a is equal to r, which is the modulus times what? Modulus times cos theta times cos theta. Therefore a is equal to r. The value of r here is that. The value of r is 5.831. Then times cos of angle. Angle here is 59 times cos 59.04. So you multiply this one and then you will get the value of a here. Multiply it. So press 5.831 times cos 59.04. Therefore here you will get 2.999. Then now just round it up to be 3. So A is equal to 3. That is the value of A. Now let us come to B. So for B, B is equal to R sine theta. See, this is the difference. Therefore, B is equal to R, which is 5.831 times sine of angle, which is 59.04. You see, 0.04. Okay, so when you press 5.831 times sine 59.04, you will get value of B as 5. So you will have 5.000. So you have to round this one off to be 5. So A is equal to 3 and B is equal to 5. Now you can express it in a rectangular form by writing Z is equal to A plus BI, where A is what is 3. Z is equal to 3 plus 5I. So this is the rectangular form of this complex number, of that complex number. So that is it. So you have to get A, which is R sine cos theta, and B is R sine theta. So simple as that. You can see the final answer here is Z is equal to 3 plus 5I. That is how they obtain those ones. So if you can follow what they have been their steps, so you can follow the steps. So you can see there how they have solved it. Okay, that is all for today. Next time we are going to discuss this exercise in separate video. So then don't worry about the exercise, we shall do it together. So thank you so much for watching this video. Please make sure you subscribe and also share it, because it is a motivation to us. So thank you so much. God bless you. God bless South Sudan.